Alright, the last thing from the 5.1 notes is a special type of application of the indefinite integral. Remember, the indefinite integral is the integration, the process of finding the family of antiderivatives, alright, the indefinite integral. So what we're going to be looking at in this section is what's called initial value problems. Alright, so suppose that an application gives us a rate of change function, alright, tells us a derivative. Alright, so we're given a derivative. Alright, again, these are called differential equation, right, the derivative. And so again, we're given f prime of x. Right? We want to find the original f of x, and the indefinite integral gives us all the possible original functions. And what we need is, well, we need to have some piece of information, which is why it's called the initial value problem. We have to be given some initial information so that we can find the real number value that goes along with it, right? That constant that makes it the specific function we're looking at. Alright, and so initial value problems is we use the indefinite integral, we use integration of the derivative, right? So the derivative is inside my integral function, and we find the general antiderivative and tack on this unknown constant. And so what we know is my original function f of x is my general antiderivative plus some constant. And then what we have to do is, well, how do we figure out c? There's infinitely many possibilities for c, right? And that's what we want to figure out. Well, we want to find the c value that we're looking for, right? The specific function that we're being asked to find. And so this is why it's called an initial value problem, because they have to give us an initial piece of information. We have to be given not only the derivative, but at least one value from my function. And it can be given as either a point, we know a point on my graph, or we know the function value, which again, those are the same things, they're just different ways to give it. Function value AB is exactly the same as the point at x equals A, y equals B. And so what we do is, well, this was all possible, right? This is all possible original functions. That have that derivative f prime of x. We plug that information in to solve for the one that we're looking for. So we find the function value, we plug that information in, and we solve for the constant that's unique to this problem. And it is unique. It's the one function that has that value and that derivative. Alright, and so that's what these are, initial value problems. Alright, so the first couple examples are just kind of straightforward generic examples, and then we'll get into a few applications. Alright, so an example would be, suppose this is my derivative. Alright, so my rate of change function is the 5x squared plus 3x minus 7. And so we want to find the function that has this derivative, and they give us an initial value, right? When I plug 0 in, I should get 9 out. That's the initial value part. Alright, there should be one unique function with that derivative and that function value. Alright, well, first we find all possible functions by taking the antiderivative of the derivative, undoing the derivative part. Alright, so again, this gives me all possible function values, or function expressions. Alright, using my rules, I add 1, divide by that, so 5x cubed divided by 3, 3x squared divided by 2, minus 7x plus some unknown, right? That's the indefinite part. Alright, so this is all possible function values with this derivative, right? There are infinitely many functions with that derivative. Well, I want the one function that not only has that derivative, but also has the function value. When I plug 0 in, I get 9 out. Alright, and there should be one unique function when that happens, and so what we do is we plug that in. Alright, when I plug 0 in for x, I should get 9 out for y, and so that's what we do. Alright, so I'm going to plug 0 in. Well, those are all going to 0 out when I plug 0 in. And so my constant value has to be 9. This is a nice case because 0 is just a nice value to plug in, and that's not my answer. Right? That just gives me my unique function value. That means the function I'm looking for. Right? Then the answer is the function. Y equals f of x is my 5/3 x cubed plus my 2/2 x squared minus 7x, but instead of some unknown c, I now know my constant value is 9. And so that is a unique answer. That is the only function with this derivative and this function value. Alright, so it's the only function that has those two parts to it. Alright, it has this derivative. If I take the derivative of this function, I will get the 5x squared plus 3x minus 7. And when I plug 0 in, I'll get 9 out, and that's unique. It's the only function that has those two properties. Alright, so let's do another example. Alright, so I've got my function f prime of, my derivative of my function f prime of x, which is 5e to the 2x. And they tell me that this is an initial point on the graph of my function. Alright, I want to find the unique original that has that derivative and that point on its curve. Alright, so again, first thing I want to do is, well, I want to undo the derivative. Alright, I want to find all possible functions, and so I've got to undo my derivative, so I find my antiderivative. And so remember, this is my e, and remember there's the 2 to the x, so I've got to remember my rule is 5e to the 2x. Divide by the 2, divide by that k value, and then plus some unknown c. Alright, that would be all possible. Again, this is all possible functions. Alright, then we also know that when I have 0 for x, I should get 1/2 out for y, which means, again, I plug 0 in, I should get 1/2 out, and I'm going to use that information to find the constant that's specific to this problem. Alright, so I'm going to use this information. I might change that to 1/2, just to be consistent with my 5/2. Alright, so I plug 0 in, so 5/2 e to the 0, right? I'm plugging 0 in for x. 0 is the x value, 1/2 is the y value. Plus c, solve for c, so I get 1/2 equals 5/2 plus c. Move my 5/2 to the other side. Alright, so 1/2 minus 5/2 is going to leave me with negative 4/2, which is going to come out negative 2. Alright, remember, that's not my answer. That's just the constant I'm looking for. Sometimes students will leave that, oh, my answer is c equals negative 2. Alright, that's not what the problem's asking for. It's asking for the function that has these two things. Alright, that has this derivative and this point on my curve. Well, the only function that has those two things is the function Alright, this would be my 5/2. Oops, 5/2. E raised to the 2x minus 2, right? This was all possible ones here. Alright, then I found the one I was looking for was with a constant negative 2. And so this is the function that solves my problem. That's the function. And that's a unique function. It's the only function when I take its derivative, and you could check it out. If you took the derivative of that, it should be 5e to the 2x. And when I plug 0 in, I should get 1/2 out. And it is. If you plug 0 in, now you can test it out and make sure it is, but when you plug 0 in, you should get 1/2 out. Alright, and so there's my unique function that satisfies both of those two pieces of information. Alright, so now we're going to do applications. Alright, so same idea, but more in terms of, we're going to stick with cost, revenue, and profit type applications. Alright, suppose that we have this marginal function, which, remember, the marginal function is the derivative. Alright, so the marginal function for profit, which is just the derivative for my profit function, is given by that equation. Alright, so my rate of change function is 2.6x raised to the 0.1. Alright, we want to find the original profit function if we know when they sell no items, profit will be a loss of $40. And so that information means that's my initial value. If I have 0 items, so that's my x value, right? No items would represent an x value of 0. My profit comes out a loss, so it means a negative $40. Alright, and so there's my initial piece of information that I need to get to C. Alright, so first thing I do, though, is I undo my derivative to find all possible profit functions. All right, and then I use my initial value to find the specific one that we're asked to find. All right, so all possible profit function, well, this is my power rule. 2.6 comes along. I add 1, so adding 1 gives me 1.1, and we divide by 1.1, and then there's some unknown constant I have to figure out, which is where this piece of information comes into play. All right, when I plug 0 in, I should get negative 40 out. So that means when I plug 0 in for x, negative 40 should come out as my profit value. All right, so when I plug 0 in, this zero's out, and so that means my constant's negative 40. All right, so that's not my final answer, my profit function, which I'll take care of the fraction in a second. All right, and so there's my profit function, but remember, this is an improper fraction. So there's a couple ways you can take care of it. You can just recognize that if I multiply by 10 over 10, it's 26 over 11, or you can use your calculator. Take 2.6 divided by 1.1 and then hit your fraction key. Again, it's more proper to write it as the fraction 26 over 11, x raised to the 1.1 minus 40. All right, and like I said, that's just more proper to write my profit equation. All right, so there's the answer. There's my profit function that has this derivative. If I took the derivative of that function, it would come out 2.6x to the 0.1. When I have 0 items sold, when x is 0, profit will be a negative 40. So if I plug 0 in, I'll get negative 40 out, and so there's my unique function. Right, then we're usually asked to use it. All right, so I have to find it first before I can use it, and so that's the second question. All right, find the profit if they produce and sell 1,000 items. All right, so let's just take that profit equation and plug 1,000 into it. All right, it's dollar amount, so make sure you put units. So it's $4,716 and about 7 cents in change. All right, and there's the answer to part B. All right, next problem, very similar to that. Problem 2 involves a cost function. All right, a derivative of the cost function. Remember, marginal cost is the derivative of the cost function. All right, so this is the derivative. All right, so furniture company has a marginal cost, which again is a derivative of the cost function of 0.6x squared minus 2.4x plus 50. All right. Then they tell us a couple of pieces of information. The total cost to produce, so this is where their total, I'm assuming this is where their production level is. When they produce 25 tables, it cost them $1,020. And so that's an initial value. All right, the cost of 25 items, right, X's tables, is $1,020. And so there's my initial piece of information. And then there's the second part. What's the total cost to produce 30? And so I'm going to come back to that. That's the second part of this question. All right, in order to find that, I have to find my cost equation. All right, so find cost first. Find the cost function. All right, in order to find my cost function, first thing I have to do is undo the derivative. All right, so take the antiderivative or integration of my rate of change function to find all possible cost equations. All right, so this is going to come out 0.6x cubed divided by 3 minus 2.4x to the second over 2 plus 50 times x, and then there's some unknown c, right, which is where this piece of information comes into play, which is why they had to tell me an initial value. When I plug x in, right, when I have x items, it should cost me 1,020, and so that's what I'm going to use. All right, when 25 goes in for x, my cost equation should equal 1,020. All right, that's the cost that comes out. And so I'm going to plug it in, and when I plug it in, I'm going to go ahead and reduce this. I can take my 0.6 and divide by 3 to reduce it to 0.3. And then remember, I'm plugging 25 in for the x value. Same thing here, I would take 2 and divide it into 2.4 to reduce to 1.2. 25 squared plus 50 times 25, and then my cost. So simplify this. All right, so it's equal to 1,020. Multiply that out on the calculator, and then don't forget there's the plus c. So when you multiply that out on the calculator, that comes out to 3,625 plus c, and then solve for your c value. Alright, so I'm going to subtract that. And so my c value, my constant, is negative 2,650. Alright, so now I know what this c value is. So my cost equation, which I'm going to write, since I'm running out of room, I'm going to erase this up here and write it up here, and then answer the question that they're asking me to answer. Alright, so my cost equation for this problem is I'm simplifying this, that's 0.3x cubed minus 1.2x to the second plus 50x, and then I found my c value was negative 2,650. Alright, so there is my unique cost function. That gives me my answer. Alright. If I take the derivative of this function, it should equal this original expression, right? The derivative of that expression should be that derivative of my cost, and it should satisfy this initial value. When I plug 25 into this function, I should get out a cost of 1,020. Alright, so there's my cost equation, and then the last question is then asking you to use it. What is the cost to produce 30? So they're currently producing 25, it cost them 1,020. Now I want to know how much it costs to produce 30 tables. Well, you take your 30 and plug it into this equation we just found. Alright, it's a dollar amount, so make sure you include your units. So when they produce 30 tables, it should cost them $3,170. Alright, and there's my final answer. Alright, the next example. Next example is a profit example. Alright, a company determines the marginal profit. So there's my marginal profit function, which again represents the derivative, the rate of change, when they sell digital cameras. If the total profit for producing 20 digital cameras is $2,500, what's the profit to sell 50 cameras? Alright, so that's my final question I'm looking for. This is my initial value. When they sell 20, right, that's my x value, profit is 2,500. And so there's my initial value. 20 goes in for x, 2,500 comes out for the y, which represents the profit part. Alright, there's my initial value that I'm going to need in order to find the correct profit equation. Alright, so first step, find my profit. Alright, so first thing, undo the derivative by integrating to find all possible profit equations, and then use my initial value to find the specific one we're looking for. Alright, so this is going to come out negative 0.03 x cubed divided by 3, negative 0.2 x squared divided by 2, 175x plus some unknown constant. I'm actually going to clean this up before I move on, just because it makes it a little easier, and I probably should have done that for the last example. Alright, so there's my profit, all possible profit equations, right? All of them that have this derivative, right? There are infinitely many functions that have that derivative. Alright, that's what they look like. Now I want the one that not only has this derivative, but has this initial value. And so I'm going to use that piece to find the one that I'm looking for, find the constant that matches. And so when I plug 20 in, I should get 2,500 out, right? That would be the profit that comes out. And so 20 goes in there for x. Alright, so 2,500 comes out when I plug 20. So again, you're going to plug this into the calculator. And so it should be a number plus c. So again, this, just be sure you're careful when you plug in that 20. Alright, comes out 3,380, and so I've got to move that to the other side to find my cost. or sorry, constant, not cost. All right, so the unique C value for this function is negative 880. All right, so again, I'm going to erase this up here to write down the profit equation that we're going to use to solve the problem. All right, so my profit, so I now know what the C value is. That C value is negative 880. All right, so my profit equation for this problem is negative 0.01x cubed minus 0.1x squared plus 175x minus 880. All right, so there is the profit equation. When you take its derivative should come out that derivative. And when I plug 20 in, I should get out 2,500. All right, so this is the unique function that makes both those two things true. It has this derivative and it has this initial value. Well, that's the profit equation that I want and that I'm going to use to figure out, well, how much will they get in profit if they can raise sales from 20 to 50 cameras. And so now I'm going to plug 50 into this function I just found, and it should come out a dollar amount because it's profit. All right, so I'm plugging 50 in here. All right, just make sure you're careful when you type it out. It should come out $6,370 in profit, and there's my final answer. All right, we're actually going to stop there. All right, I'm going to skip problem number 4. The numbers don't come out quite as nice as I wanted them to. And if you understand the previous problems, these are going to be the ones that typically show up on the tests and things. So make sure you kind of look back at these. These are the problems that will be on the test and the homework and stuff. So I'm going to throw this one out. Don't worry about this one. So I'm going to omit this one. And so we're going to wrap it up there. So that finishes up 5.1. All right, in the next section, we'll start 5.2, which is undoing the chain rule, special process to undo the chain rule. All right, so we're going to wrap up the video there.